Okay, so let's take a look at the part 3 of this, part 4 of this problem. Part 3. Part C. This is still C here. So I found that if I wanted to find the distance between 1.866 and 3.520, I'm going to integrate the function that I had between there. And I actually did that in the calculator. And I got 106.1692, which, by the way, is not the correct answer. I would only get 2 points for this part of the problem. And the reason I'm only getting 2 points is I rounded wrong in the past. When you make a mistake, you're going to lose a point for it. This should have been 3.519 is what it should have rounded to. So if I put that in the calculator, 3.519, I get 106.1092, which is going to be the correct answer. And when I write it down, it should look like this: integral 66 to 3.519, 45 radical t cosine 0.063 t squared dt equals 106.1092, which I round to the thousandths place, which equals 106.109. So the reason I need to do that on this problem is on any DIVA problems, if you start out with velocity and you want acceleration, take the derivative. If you start out with velocity and want displacement, you're going to integrate the problem you have right there. And that's probably what's going to happen on the last part of this problem. Let's take a look. It says at time 0, particle Q is at position x equals 90. So Q of x is equal to negative 90. Use the results from the part B of the function, and part C approximate the distance between particles P and particle Q at time t equals 2.8. So in order to do that, I got to find the position of P and Q at 2.8. So the position of P, or x of P, which you can write with any symbols you want, would be equal to the integral from 0 to 2.8 of v sub P. So the integral of velocity, you can write it like this. And we found that already. The integral of velocity was 40.75. And then I could find, so now to find x of q, that's going to be equal to the integral from 0 to 2.8 of v sub q. So that's how far it went. Plus, it's always about where it started as well. So it's negative 90 plus that distance that it's that went over the course of that integral. If I put it in the calculator, negative 90. For this answer, I get 135.9376. Add them together, I get 45.938. I'm going to highlight those two. Those two are the things that tell me where they are, but the question always has an extra little piece. It's always going to be thinking how far apart they were. If I did those two, I would have gotten 2 points for it. The last thing I have to do is find the distance between them, which is going to be 45.937653 minus 40.75 equals 5.188. Don't put units if it doesn't ask for units, which the problem didn't. So a lot of stuff going on, easier to harder. You're either going to be estimating values on a table, using velocities, or using integrals. Okay, we'll save this one. We'll get our next video up in a few minutes.